Welcome to Making Stuff with Chris DeHut. Today we're going to take a look at interrupts with MicroPython on the Raspberry Pi Pico. What we're going to cover will be what they are, some applications of them. We're going to take a look at the two parts of an interrupt, as well as go through an extensive example, and we're going to manipulate that example a little bit to show you faults in possible things that you could be doing and how to get around them, especially with re-entrance of the handler while it's running, as well as dealing with switch bounce. So with that, the first thing we're going to do is take a quick look at the fritzing diagram to show you how this circuit is set up. Looking at the fritzing diagram, the circuit's rather simple. We're going to include two elements. We'll have a switch to cause the interrupt to do something, and then our LED will be what we're going to control or deal with in that interrupt. Wiring is quite straightforward. I'm coming off the Pi Pico with a 3.3 volt wire here. Bring that up to the positive rail on the breadboard. That'll go into one side of my switch. This is a Momentary push button switch. We come out the switch, back over to the Raspberry Pi Pico on GP pin number 15. Down below, we've got a ground wire coming off the Pi Pico into the ground rail on the breadboard, over to a 220 ohm resistor. That's just a safe value resistor for the LED, not something precisely calculated. And then from the LED on the positive leg, which is the long leg of the LED, we're going to come back into the Raspberry Pi Pico on pin number 16. And that's going to be the positive voltage supply to the LED. Coming over to the actual circuit board, or the breadboard, here we can see the 3.3 volt wire coming around to the positive rail, to our blue wire going into our push button switch. Sorry, I've got a yellow push button, not a red one like on the fritzing diagram. From there we come back out of this Momentary switch, and it goes back into pin number 15 on the Pico. Over here we're coming out of the Pi Pico on the ground and putting that on the ground rail of the breadboard. We follow that over into a resistor, 220 ohm resistor, into the short leg of the LED. Coming out, long leg of LED connects to the Raspberry Pi Pico on pin number 16, and that's where, of course, the positive voltage would come from when we turn that output on. Now, if you're not familiar with interrupts, let's take a moment to discuss that. An interrupt is a way of interrupting your program as you've written it to run and taking care of a very specific task. For example, as you're writing microcontroller programs, you'll almost always have a main loop. That's a while loop that runs infinitely, and you just go over and over and over in that loop, taking care of the tasks that need to be attended to. But certain situations, you don't want to just continually pull or check each time through that loop. So when something happens, a sensor or a switch comes on, you want to interrupt that loop, jump over to another section of code, take care of whatever task has to be handled, and then you would go back to your normal main loop in your program and continue on. So they are a quick jump out to take care of a piece of business. So let's take a look at the actual program now. And we're going to spend quite a bit of time discussing this, and I'll be bouncing around a little bit, but hopefully you can follow along. As almost all programs with the Raspberry Pi Pico and MicroPython, you're going to import your machine library, which gives us access to the hardware, primarily the pins. We're going to import our time module, micro time module, so that we can add some sleeps and so forth. Again, very common in many Python programs. Here, we're going to create a warning LED, and that will be what is in response to the interrupt. So the interrupt will occur, and then we're going to turn this warning LED on. In reality, of course, you might have a whole bunch of different stuff you want to take care of, but this is just an example for us to follow. And that's on, that warning LED is on machine pin number GP16, and we've configured it as an output. And I'm going to turn it off to start with. This is the handler that we're going to be using. This is what will be executed should an interrupt occur. But before we cover this, we're going to go down a little bit further. Here would be your basic main loop or endless loop in your typical MicroPython program. You always have a loop that'll run and take care of all your activities. In here, you could be polling different input devices, checking analog voltages, calculating values, processing data, writing data to an SD card. All kinds of data can be processed in this area of your program. So you would have this endless loop. Now, you could pull a switch every time through the loop to see if it went high or low, and then respond accordingly. But if that on or off of the switch happened as you were checking other things in this part of the program, there would be no response to it. If it went on and off very quickly, you might not be polling it at that exact millisecond or microsecond in time. So you could skip right over a state change of a switch. And that's where interrupts are really a powerful tool. And as I mentioned, we have two things that we got to take care of to deal with an interrupt. First, we need to define it and define a handler that's going to take care of that pin's change in state, and then the actual routine that will do it. And we commonly refer to this as the handler. So let's go back down to here, and what we're going to do is look at how we're going to create an object for our push button switch and the change of its state. So we're going to create an object by instantiating it with, we're going to call it PB switch, push button switch. And we do that with machine.pin, part of our machine library. It's GP pin number 15. And we're going to set it up as an input, machine.pin.in, capital letters IN. That sets it up as an input. And then I want to set it up with a pull-down, internal pull-down resistor so that I know or pretty well assured that that'll be at 0 volts and not floating around with some little microscopic voltage that could affect our readings. The next thing we need to do is set up the handler. So we're going to say push button switch.irq, interrupt request. The trigger will be machine.pin.irq rising. So it'll be this switch. We're looking at the pin associated to that switch, and when the voltage is rising, or the voltage on that is falling. So what I want to do is actually check both the rising change and the falling change, and both of those will cause the handler routine to execute. And here's where we define how that interrupt is going to be handled. As soon as either of these two states are happening or happen, the handler will execute and we will run this routine. So we'll go up here. Here is that routine. This is our interrupt handler for our PB switch. And incoming from that event will be the pin number. And sometimes that's handy. In this particular case, it's not important for what we're doing. I'm going to be using an external or a global variable to hold the current state of the switch before it gets changed. And this will make a little more sense in a few moments here when we demonstrate how this helps us. But the very first and most important thing we got to do is turn off the push button switch IRQ, interrupt request handler. We set it to none. The reason why we want to do that right away at the entrance or the start of this subroutine is that if something's happening very rapidly, for example, we're going 10,000 times a second in this loop, we don't want 2 or 3 or 4 interrupts to hit one right after the other, milliseconds or microseconds apart. That would create a whole lot of confusion because several of these routines are going to try to run and deal with it all at the same time. So to bypass that completely, we turn the handler or set the handler to none, meaning if an interrupt does happen, it won't run this routine. So the purpose of that is to prevent re-entrance from multiple interrupts within a microsecond or a very fine, small period of time. Now down here, you're going to see I've got a comment on this line and a comment on that line, and we're going to show you how those two lines will help you and perform better than our normal decision line. Now for this particular decision line, we know that here we've either seen a rise in voltage or a fall in voltage on this pin. And from that, I'm going to use a decision here. If the push button switch value is equal to 1, meaning that switch went high, I want to execute this code, in which case I would set the PB switch state global variable to 1. And that way the rest of the program knows that that is also high. And then here would be the code that you're going to do or perform your action in the real world to deal with whatever condition or exercise or activity has to happen because of this condition. In our case, our very important task is to simply turn the warning LED on by setting its value to 1. And then I'm going to print the statement on. And that's going to serve as another purpose for us in this demonstration in a moment. Now, I mentioned we're going to check for either the pin going high or the pin going low. So this would be, if we came into the handler, we would be looking at if the push button switch dot value is equal to 0, meaning that it is now not active or the voltage is low on it. In which case, I'm going to set the global variable to 0 so that the rest of the program knows what state we're in. I'm going to turn my warning LED value off because we're done with that warning that was created with this activity. And then we're going to print just off, meaning that communicating that the switch is off, and we'll give it a new line to make it a little more legible and readable down here. And then finally, now that I've gone through, we've turned off the handler, performed all the activities that needed to be performed, I want to turn the handler back on. And to do that, I just simply say, instead of none for the handler, I'm going to say use PB switch interrupt. And that is this routine or this function name right here. And as exactly as we did over here. And again, that was to prevent any of these trigger functions from hitting into this routine at the same time while data is already being processed. Now down here, I'm going to create that variable that we're using in our routine up here, the global variable PB switch.state or underscore state. I'm going to create that and set its value to the current state of the switch. So when we start the program, this will be set to whatever state the switch is in. And then I'm just going to print that and show what state it is so that I have a point of reference as I'm testing and debugging the program. And then finally, we're back into the program's main loop. So now what will happen, we're going to run this, and we're going to see some problems, and then we'll talk about dealing with those. To start with, we'll just look at what happens on the breadboard. I've just hit start, it's running, and now I'm going to hit the push button. I'm holding it down, you'll see our LED is on. Release it, the LED comes off. So the behavior is exactly what we wanted. We hit this, the interrupt occurs, turns the LED on. Then when the voltage drops because I released the switch, the LED turns off because another interrupt was triggered. Now let's look at that over on the computer screen. And what I want you to see is the area down below here where it's printing out either on or off. I pushed it in. We see our on. I'm going to release it. And we got a whole bunch of on, off things. Not real logical looking, is that? You would expect it to be on, off, etc. So I'll repeat pushing the button. I'll push it in, on, off. That was good. On, off. Oh, we got 2 offs that time. Now, in reality, you could probably work around that in code. And one of the most common advices to deal with this is to put a pause or a dwell or a sleep in your program. And I've found that to be very unreliable because what we're trying to deal with here is switch bounce, and that's an unknown. It's a random amount of time. And if we put a fixed amount of time up here somewhere to let that switch bounce settle, well, guess what? If the bounce takes a little longer, then it's not going to catch it up here, and then the problem kind of keeps going. And because of that, I've come up with a different way of dealing with this, not only for interrupt handlers, but anytime there's a switch input where it isn't a perfect on or a perfect off. This will help solve that problem. Now, earlier, I explained that we have this global variable PB switch state, and we initialized it down here at the start of the program, just before we went into the main loop. And then within our conditions here, we updated that. But we never did anything with that variable so far. We just set it to a value, but didn't make any comparisons with it. And now we're going to. What I'm going to do is I'm going to comment out that line and activate that line and that one. And you'll see right away what our difference is. In this case, I'm just checking the switch's current state as it is electronically. I'm not looking at our variable of the push-button switch state. So based on just looking at that, this would allow any time that the push-button switch is active, it would execute this code. But that's really not what I want to do. I only want to execute this code when the switch is active or just turned on, and the state is not the same as this. That way I know there was a change in state. Just like here we're seeing there's a rise in voltage. Well, technically that rise in voltage is a one-time event as opposed to being on. If we checked on, well, it's always going to be a trigger because it's always on or it's always off. So we have a one-time, one-moment event here, and I'm comparing that moment in time against what the real switch state was prior to that moment in time. If they're not equal, then I want to execute this code. So, to reiterate, I'm looking at the current state, electronic value, the voltage value of that switch, and if it's a positive value, meaning that it's on, and the current value prior to the interrupt was 0, meaning it was low, so it's now on, was low. Let's change this variable to on or high, and we'll perform our function that we want the interrupt routine to actually handle. The same is true down here. If the voltage was falling, so now it's in that low voltage state, and it was high, then we'll set this to match the current state, which is low, and then we'll perform our activity here. And our function in this case is up here, simply turn the LED on and turn the LED off. So by doing this particular comparison, the way I've got it structured, it will only execute this code if these two conditions are met, and that eliminates an awful lot of problems with switch bounce and even potential reentrance into the subroutine. So you may or may not want to use it. I would suggest you study this code very carefully and experiment with it a little bit so that you understand how it works. So let's go ahead and run this code, and I'll just run it from here. We'll get this all set down here. I'm going to clear it out now, and then I'm going to push the button. It's on. Release it, it's off. Notice I got one on, one off. Isn't that much cleaner than what we had before? With just a few lines of code, we can solve a very complex, cumbersome problem and not go through the, I'm going to call it a hack, of just dealing with throwing a dwell in here to let the switch bounce pass or whatever the case may be. So that is the importance of using that state variable, why it's a global. Often those are frowned upon, but hopefully you appreciate its value now, and adding just this little bit of code here to add that condition or that second condition to perform the state. Hopefully that should pretty well get you through working with switches and interrupts. Now there is one more thing I want to point out, and it has to do with this line here. In our case, I wanted to trigger the interrupt handler anytime the value was rising or anytime the switch value was falling. And that way we could perform the two things. Rising, turn on the LED. Falling, turn it off. Now that is most probably not the most common case. More often than not, somebody will just want to look for a switch rising or a switch falling, but not both at the same time. So here's how you would handle that. Now this is the example we have right now. Our trigger is the pin rising or the pin falling. If I just want to check for rising, that's all I would write in there. I would eliminate the pipe symbol, that guy, and just leave it as the end of that part of the statement. And likewise, if I wanted just the falling portion, again, I would eliminate this part of it. We would just simply have machine.pin IRQ falling. So that's how you can get a trigger based on either a rising going high switch, a falling going low switch, or either a rising going high or a falling going low switch condition. Hopefully that isn't too complicated, and hopefully you can get your head wrapped around it. And maybe even this would be a great time if you're new to interrupts and dealing with change of state in switches. This would be a great program to experiment with. You've got the LED on the board to see feedback. You've got the feedback here in the shell area of your Thani environment to see what's going on. And that should help guide you with what you're doing with your interrupt. As mentioned, interrupts are a special case situation. You want them to take care of something that has urgency and importance, and it needs to take priority over the normal functions in your program that are executed in your main loop. With that, they can be very powerful tools to help solve a number of problems. But as with any inputs on either a micro or even an SBC type computer, there can be conditions that you'll have to deal with, such as switch bounce or re-entering interrupt handler, or a function in this case that is a interrupt handler, of re-entering that while it's currently executing code. And that can kind of mess things up, and it gets very complex to debug and figure out. So with that, I hope you've got a much better handle now on interrupts, and we'll be using those in future videos dealing with switches, kind of like what we've done here. So hopefully that'll do it for you. That'll do it for this video. If you've got comments, be sure to post them down below. If you've enjoyed this video, I certainly hope that you'll subscribe to it, maybe even give me a like. That will certainly help secure the future of this channel, because without subscribers and without positive comments and viewers such as yourself, the channel simply doesn't survive. So with that, thanks very much for watching, and I look forward to seeing you in the next video.